students, in geometry we study about various shapes. In triangles we study about terms like incenter, circumcenter, centroid and orthocenter. Today we are going to explore the position of incenter, circumcenter, centroid and orthocenter in different types of triangles. For doing this activity, we require the following material: some colored papers, a ruler, sketch pens and a pair of scissors. Let us explore the position of centroid in a triangle. We will be doing this activity for 3 different types of triangles. What is a centroid? A centroid is point of concurrency of medians in a triangle. What is a median? A median is line segment joining vertex to the midpoint of the opposite side. Let us explore the position of centroid in an acute triangle. We have an acute triangle LMN. To get the median from the point L, first of all we will get a midpoint of the side MN. Fold the paper along MN. This is how we get midpoint D of the side MN. To get the median, we will make a crease joining the point L and D. Unfold and on the crease draw the median LD. We know that in a triangle we have 3 vertices, and here in this acute triangle LMN we have the vertices L, M and N. As we have taken the median LD, we will be having medians from the point M and N. For having the median from the point M, first we will have the midpoint of side LN. E is the midpoint of side LN. Form a crease joining M and E. This is how we get the median from the vertex M, and the median is ME. Similarly, we will get another median from the point N. For doing this, we will first of all find the midpoint of ML. Fold ML such that the point M falls on L exactly, and this is the midpoint of ML, and I have named it as F. Form a crease joining NF. NF is the third median. Now observe carefully that all the 3 medians meet at a common point, and this point is called centroid. Observe that the point G, which is the centroid, lies inside the triangle LMN, where LMN is an acute triangle. Now we will take a right triangle. Here I have a right triangle ABC. By following the same process, we can find medians from the point A, B and C. Observe carefully that in right triangle CAB, the centroid G lies inside the triangle. Now we will take the third case, a case of an obtuse triangle. We have an obtuse triangle RPQ. By following the same process, we can have medians in this triangle QPR. By paper folding, you can get the medians, and observe carefully that all the three medians are meeting at a common point called centroid. Now observe that the position of centroid in all the three types of triangles, whether it is an acute triangle or a right triangle or an obtuse triangle, the centroid lies inside the triangle. Dear students, now we will explore the position of incenter in different types of triangles. We have with us three different types of triangles: an acute triangle, a right triangle and an obtuse triangle. What is an incenter? Incenter is point of concurrency of angle bisectors in a triangle. What is an angle bisector? An angle bisector is a ray which divides an angle into two equal parts. Let us see the position of incenter in an acute triangle. Here we have acute triangle LMN. To get the angle bisector of angle M, fold the paper in such a way that the side LM and MN coincides with each other. Unfold, on the crease draw the bisector. Here we have bisector of angle M. Similarly, we will get the bisector of angle L. Fold the paper in such a way that the side LN and LM coincides with each other. Unfold and on the crease draw the bisector of angle L. Now we will take the bisector of angle N by following the same process. Fold the paper in such a way that side LN and MN coincides with each other. Unfold and on the crease draw bisector of angle N. What do we observe? We observe that the bisectors of angle L, angle M and angle N meet at a common point which is called incenter. Similarly, we will find the position of incenter in a right triangle. We have a right triangle PQR. By following the same process of folding, we can have bisectors of angle P, then angle Q and angle R. Unfold and see that all the bisectors meet at a common point called incenter. Now take the case of obtuse triangle. We have obtuse triangle R, P and Q. Use the same process of folding. We have angle bisector of angle P. This is angle bisector of angle R and this is angle bisector of angle Q. Unfold it and see that angle bisectors of angle R, angle P and angle Q meet at a common point called incenter. Now observe carefully that in all the three types of triangles, an acute triangle, a right triangle and an obtuse triangle, the incenter lies inside the triangle. Now we will explore the position of circumcenter in different types of triangles. What is a circumcenter? A circumcenter is point of concurrency of perpendicular bisectors of the sides of a triangle. You know how to find the perpendicular bisector? We have done this activity earlier to have a perpendicular bisector through paper folding. Let us see the position of circumcenter in three different types of triangles: an acute triangle, a right triangle, and an obtuse triangle. Here we have an acute triangle AQB. To get the perpendicular bisector of QB, fold along QB such that point B coincides with point Q. Form a crease, unfold it, and on the crease draw the perpendicular bisector of side QB. Similarly, to get the perpendicular bisector of side AB, fold along AB such that point A falls on B completely. Unfold it and on the crease draw perpendicular bisector for AB. Now, get the perpendicular bisector of the third side of triangle, that is AQ. Fold along AQ such that point Q falls on A completely. Make a crease, unfold it, and on the crease draw perpendicular bisector of AQ. What do you observe? We observe that the perpendicular bisectors of all the three sides meet at a common point C, and this point is called circumcenter. In an acute triangle, the circumcenter lies inside the triangle. Let us see what happens in the case of a right triangle. We have a right triangle QAB. We will have the perpendicular bisector of side QB, then side QA, and then side QC. Observe carefully that perpendicular bisectors of all the three sides meet at a common point which is called circumcenter, and observe the position of circumcenter here. In a right triangle, the circumcenter lies on the midpoint of hypotenuse. Let us now observe the position of circumcenter in an obtuse triangle PQR. It is very interesting. First of all, we will have perpendicular bisector of side PQ, and then we will have perpendicular bisector of side QR, and then we will have perpendicular bisector of side PR. Unfold and observe that all the three perpendicular bisectors, they meet at a point C. This point C is called the circumcenter, and observe the position of circumcenter. The circumcenter in an obtuse triangle lies outside the triangle. So, we have seen that the circumcenter in an acute triangle lies inside the triangle. In a right triangle, it lies on the midpoint of the hypotenuse which lies on the triangle, and in an obtuse triangle, it lies outside the triangle. Now, we will see the position of orthocenter in various types of triangles. For doing this, we will draw an acute triangle on a plain sheet of paper, say A, B, C. What is an orthocenter? Orthocenter is the point of concurrency of altitudes in a triangle. How many altitudes are there? As we have 3 vertices in a triangle, we can have 3 altitudes in a triangle. What is an altitude? An altitude is perpendicular drawn from each vertex on the opposite side. Now see, here we have an acute triangle ABC. We have to get the altitude from vertex A. Now see what we are going to do. We will make a crease along the side BC. I am writing here BC. This is the side, and to get the perpendicular on BC from A, we will fold along BC such that we get a crease passing through A and perpendicular to BC. Unfold it, and on this crease draw the perpendicular from A on BC. This AD is perpendicular to BC. Similarly, do for the side AC. We will fold along AC, and to get the perpendicular from B on AC, fold along AC such that you get a crease passing through B and perpendicular to the opposite side, that is AC. This is A and this is C. On the crease, draw the perpendicular on the side AC. Now we will do the same for the side AB. Fold along AB, this is A and this is B. Fold along AB such that you get a crease passing through C and perpendicular to AB. Unfold it and draw a perpendicular from C on AB. What do we observe? We observe that the 3 perpendiculars meet at a common point, which is called orthocenter. Now let us see in this triangle ABC, where ABC is an acute triangle. AD is perpendicular to side BC, BE is perpendicular to side AC, and CF is perpendicular to the side AB. The 3 altitudes, they meet at a common point, which is called orthocenter. In an acute triangle, the orthocenter lies inside the triangle. Let us see what happens in the case of an obtuse triangle. Here we have taken an obtuse triangle ABC. To get the perpendicular from the side A, we will make a crease along BC and then make another crease passing through A and perpendicular to BC. Unfold, you will find AO perpendicular to BC. To get the perpendicular from the vertex B, we will fold along AC and then we will fold in such a way that we get a perpendicular passing through the point B on the side AC. Unfold it, and this is perpendicular from the vertex B. Now, to get the perpendicular from the vertex C, we will first fold along AB and then we will make a crease passing through C perpendicular to AB. Unfold and observe carefully that perpendicular from the vertex A, perpendicular from the vertex B and perpendicular from the vertex C, they meet at a common point which is called orthocenter, and in the obtuse triangle ABC, the orthocenter lies outside the triangle. Now we will see the position of orthocenter in a right triangle. We have a right triangle ABC right angled at B. It is clear that from A, AB is altitude on the side BC, and altitude from the vertex C on side AB is CB. The third altitude we will get from the vertex B. For doing so, we will first fold like this, and to get the perpendicular on AC from the point B, we will fold in such a way that we get a perpendicular line from B on AC. Unfold it and observe carefully that all the three altitudes are meeting at the vertex B, which lies on the triangle. In a right triangle, this point B is orthocenter. Dear students, we have seen the position of orthocenter in three different types of triangles. Look here, in an acute triangle, orthocenter lies inside the triangle. In an obtuse triangle, orthocenter lies outside the triangle, and in a right triangle, orthocenter lies on the vertex where the 90-degree angle, that is a right angle, is formed. You can verify this activity by taking different types of triangles on your own.